Hello, my name is Ada. I'm a new media artist and sound artist. My practice is about creating immersive worlds that bridge physical and digital realms. Sound and multimedia installations are my main mediums. Through them, I explore sonic textures, spatial audio environments, and interactive technologies to create sensory experiences, inviting my viewer to engage with the unseen layers of their realities. Welcome to our workshop today, Into the Void. In this workshop, we'll be using Unreal Engine 5, HTC Vive Focus Vision, and NASA audio recordings. With these tools, I'm going to guide you through the process of creating an immersive sonic VR world. We'll begin by building a simple dark environment representing the void of outer space, and then add lighting to indicate different sound zones and guide our viewers' movement. We'll then use NASA space recordings, such as plasma waves and black hole echoes, as our spatial audio sound sources. Using the spatial audio and attenuation features in Unreal Engine, we'll activate these sounds as the viewers navigate through the space, creating an immersive, disorienting experience that is full of discoveries. And finally, we'll package and export our project for viewing in the VR headset. So now we've connected our headset, we are ready to go into Unreal Engine. First thing you are going to do is open up the game launcher and select Unreal Engine. And here you can launch whichever version you're using. I'm using Unreal 5.3.1. And if you're opening it up for the first time, it usually takes a moment for it to initialize the program. Here, if you've used the engine before, you can see all your past projects. Right now, we are going to go into Games and select Virtual Reality. So basically, this will open up a virtual reality template, which is a pre-built project that has a basic simple scene for you to experience with VR. And you can select your project location. This is where you can find your project file on your computer. And you can name your project here. I'm just going to name mine my VR project. And then hit create. So here you can see the template already comes with the basic scene with a very simple architecture and with objects to interact with and with light. So here you can test out basic VR interactions like teleporting and grabbing objects, experience the lighting, and experience the sounds that come with it. So this is kind of giving you an idea what VR and Unreal is like. Compared to other game engines, the advantage of Unreal lies in its high-fidelity graphics, real-time rendering, and its blueprint scripting, which we'll cover today. And now we are ready to build our own project and bring the experience to another level. To do so, go to File, New Level, and we are going to select Basic, Create. So the basic level already comes with a floor, and we can start designing our own floor plan on top of that. So remember, we're going to recreate the experience of exploring space through sound, through void, and through darkness. So here you might want to think about how the viewers are going to navigate through the space that you are creating. Maybe you want a huge open space with narrow corridors, secret pathways, or maybe you want to build a maze. This is all up to you. So now we have the floor, we need walls. And to do so, go to Add, select Shape, and select Cube. Some of you might notice that if you go to Shape, there is also an option called Plane. And you might be wondering why we're using Cube here and not Plane. So the difference between the two is when you're using a plane, you only need to see one side of the object. But for walls, we want both sides to be visible, and we want light to bounce off of both sides of it. So we're going to use Cube. And when you click onto your cube, there are a series of hotkeys. With W, you can move the cube around. And with E, you can rotate it. And with that, with the cube selected, in this mode, if you hit Shift in the rotate mode, it will rotate the cube according to fixed values. And if you hit R, you can reshape the cube, which is what we are doing here. So there you have it, your first wall. Again, you can change it to whatever shape you want. Then we can just repeat this step and create a basic layout for our scene. And right now we have our basic layout. We are ready to add in some lights. Here you can see the scene we have right now is very bright because when you go to the outline, you will see that it comes with directional light, skylight, and sky sphere. And eventually we'll turn all of these off so that our scene will be completely dark with only the lightings that we've added. As you can see here. But right now, to better see the structures that we built, we'll keep them on for a moment. To add lighting, you can simply again go to Add and go to Light. You'll see that you have a variety of options. Directional light, which is what we have in the scene, it's like the sun. It casts light throughout the entirety of the scene from one single direction. And so this is great if you're building an outdoor scene. And then there's point light. These are like light bulbs. It shines through its surrounding from one single point. So this would be great for like glowing objects like lamp. And then spotlight, imagine if you have a theatrical stage and you have spotlights on the stage. So it's like a light that focuses in a cone shape to highlight certain areas, and it's usually more dramatic and theatrical. And red light, it stands for rectangle. So basically a light in a rectangular shape. Imagine if you have a TV or a monitor or say overhead lighting in a rectangular shape, this is great for that. And skylight is what we have right now in the scene. It provides uniform indirect lighting throughout the entire scene from close to far. So since we are building a pitch black scene with light designating certain areas and guiding the viewer's movement, we're going to use a mixture of spotlight and point light. And you can simply click on it and you will see a spotlight object showing up in the scene, and you can just drag it to wherever you want it. So here on the side panel, we are not seeing the light yet, so you can adjust the intensity of the spotlight and its radius. So you can see as I adjust my intensity and radius, you can finally see the light affecting the scene in a more subtle way. So to better see its effect, you can turn off the directional light for a moment. And you can turn it back on to kind of see the structure, so you can switch in between as you add your lighting to the scene. And again, you can change the color of your spotlight. And whenever you get this error lighting needs to be rebuilt, you can just go to Build and Build Lightings Only. But basically, this is the engine rendering the lightings for you. And when you zoom in, you might also notice that the floor has this grid texture that you do not want. And to get rid of that with the floor selected, you can go to Material. We are not going to go deeply into Material today. And you can simply select a default white material that comes with the template. And now you can see the grid texture is gone. And we can just repeat that what we have done and add in a few more spotlight and then point light throughout our scene. And as you work on your scene, you can keep the directional light on, and just like what we did to the spotlight, you can, with it selected, go to the details panel and you can turn down its intensity to say around 1. And in this way, we can see both the lights that we've added and then the structures that we built. And as you continue adding lights to your scene, you might get another error, which I'm going to showcase right now. So now I'm adding spotlight into my scene in different locations. Okay, so here is the error I was waiting for. Too many overlapping shadows, shadow casts can't work. So that is because we have multiple spotlights in our scene currently, but then we also have this huge directional light. So basically, the ways that they cast shadows are conflicting with each other in our scene, but we don't need to worry about it because eventually we are going to delete the directional light to make our scene completely dark. So say right now I go and delete my directional light. You see our scene is looking so much better in complete darkness with the light guiding the viewer's pathway, and the shadow conflict error also disappear. And the build lighting error, again, you can just go to build lighting to get rid of that. So now after you've worked on your project, you should already have a variety of spotlights and point lights in your scene of various colors and radius. And there is one more type of light that we can add that behaves a little differently compared to the rest. And this actually comes with our VR template. So you're going to go to your content drawer. Here you can search for lighting. And you can drag it into your scene. So you can see this is basically behaving like an object. Just like the cube, we can transform and place it into different areas. And similarly, if I have the light beam selected and I hit R, I can reshape it like an object. For example, I might want it super tall, or I can also move it into a different location. And if I hit E, I can change its angle. I can have it shine forward, backward, however you want it. So right now this looks pretty good to me. And if you go under the light beam, you'll see that it's different from the spotlight. It's like a light shining upon us from above. And to change its color, it's also a little bit different. So have it selected and again, go to the details panel. You're going to go to material. Remember how we changed the material of the floor. So if we double click on it, it will give you this window of the blueprint, and we can just ignore the rest for now. Go into the color panel, and here you can pick a color you want your light beam to be. And you'll also see a rendering here, and hit OK and hit apply and close the window, and you'll see that the color of our light beam is changed. So now we have a good variety of lights in our scene. We can add in a little bit magic to enhance them. So first, something we can do is add in a post-processing volume. So go to Add, Element, Volume, and then Post-Processing Volume. And you can consider this as an Instagram filter that applies to our scene. So right now, it only applies to within this cube, which means that when you're inside the cube, you can see the effects of the filter, but when you are outside of it, you won't see it. And we don't want that. We want it to apply to the entirety of our scene. So have it selected, go to Details panel, and search for Infinite Extent. So now that filter will apply to the entirety of our scene. And we can activate something called Bloom. And here we can turn on its method, intensity, threshold, and convolution. We can just right now use the default values that come with it. So bloom is an effect that simulates the glow or bloom of extremely bright objects. It creates this real-world visual effect to simulate how your eye behaves when you are looking at a really bright light, and the sense of feeling overwhelmed So it adds to the reality, the realism of the scene by simulating really intense bright light sources. And you can adjust its intensity here. So you can see as you increase your intensity, the light sources and the scene appear to be brighter. And another thing we can do now that we've activated Bloom is to add lens flare. So search for lens flare, and you can turn on its intensity and threshold. And as you slowly toggle the threshold, you will see the lens flare gradually appearing. So in the real world, say when you point your camera towards the sun or towards a very bright light source, you'll notice that there are lens flares, which are these visual artifacts like light streaks, rings, or halos, which are the result of external lights bouncing off the glass surfaces within the camera. So this is a simulation of that effect. And you can adjust its intensity or even its color if you want. So this can change the color of the light streaks. And right now it's looking very intense, and maybe I don't want that, so I can adjust its threshold. So now it's looking pretty good to me. And I feel like this lens flare adds to kind of the more dreamy and immersive layer to our scene. And now you are probably really excited to experience this very first VR project that you've built. But to do so, we have to first set up our VR pawn. So you can consider the scene we have right now as an open space, an empty space, a stage without characters in it. And the VR pawn is our protagonist. It is the body that we possess and inhabit as a viewer when we travel through the space. Without it, we wouldn't be able to experience the scene through our headset. And we can simply go to our content drawer and then type in VR pawn. So this comes with our VR template. And we can select it and drag it into our scene. It doesn't matter where we place it right now. And for our VR pawn, we can import custom actions of how we want it to behave, how we want to move around in the space. And to do so, go to your content drawer and then go to VR template and then input actions. So under actions here, we can add in our own custom actions. So for this scene, I want the viewers to kind of be able to float around and move around freely, and also be able to turn around and then check out the scene from a different angle. So here you can right click, go to input action. And for the first action, we can call it IA_ move around. And then double click. Here you can put in your description. And under value type, we're going to select SS2D vector 2D, which means that after we pair our controller with this action, it will read the X and Y value of our controller. And then under modifier, I'm going to add in something called dead zone. So what dead zone does is it makes your character movement more smooth, because it would ignore the very tiny value change of your controller. Okay. And then after that's done, we can just exit this window and again go to content drawer and do the same. Input action. And then for our second action, we're going to call IA_ turn around. And then again, double click on it. And we can rename it. And here under value type, so for my turning action, for example, I want it to be on the joystick of my right controller. And as I turn the joystick on my x-axis, which means like if I turn it left and right, I'm able to shift my perspective. So here under value type, I'm going to choose SS1D float, which means that it's only reading from one axis. So for example, the x-axis. And similarly, under modifier, I'm going to choose that zone, so that again, the turning movement ends up being more smooth. Okay, so after that's done, you should see the 2 new action that we just added in your content drawer. And then now what we're going to do is, in your content drawer, search for IMC default. So this is kind of the pairing between all the actions that you have and your controller. So you see, I already have some mapping here, but I'm going to start over. And then under mapping, you can click here to add in your new action. So here, I'm going to search for IA move around, which is what we just put in. And then IA turn around. Okay. And then under here, you can add a control binding to your action mapping. So here is where you're able to select the controller you're using so that it's mapped to the action. So here, I know the controller I'm using is HTC Cosmos. And you'll see a variety of options here. So for the moving around, I want it to be on the left joystick, the left thumbstick. I'm going to map it to Cosmos left thumbstick 2D axis. And then for the turnaround, I want it to be on my right thumbstick. And then, so I'm going to do the same here. Go to Cosmos. And then x-axis. So now the mapping is done. If you don't see your controller option here, something you can check is go to Edit and then go to Plugins. So here I have OpenXR Vive Tracker and then Vive OpenXR, both plugins turned on. So you should double check if your controller don't show up on the list. If your plugin have been activated, or maybe you don't have these plugins, you can check the file link for the links for these plugins. And then now we can go into our VRPON blueprint. You can go to the item outliner here and select Edit VRPON. And the first thing we're going to do is select class settings. And here we're going to change parent class from pawn to character. All right. And after we do that, under viewport here, we're going to move the location of our camera to below. So here I can type in 90, or you can also manually just move the camera. All right. And then after that, we can go into our events graph. The first thing we're going to do is to unbind all the original actions. So here, input action turn, snap turn. So we don't want a snap turn function. We want to use the smooth turning around that we just added in. So I'm going to delete the triggered. You can hit hold Alt key on your keyboard and then use your left click on your mouse, and that will delete the connection. And I'm going to do the same with teleport. So delete all those pins. And for the grabbing, we can just ignore them. And now if you go below into the open area of your graph, we're going to add in the programming for the 2 new actions that we've just added. So right click and then search for IA move around. and then right click, search for IA, turn around. All right, and then for the move around, we're gonna add in add movement input. And we're gonna right click on the world direction pin to split it. Split structure pin. And then we're gonna right click, get forward vector, camera. And we're gonna split this return value. So this allows us to move forward towards wherever the camera is pointing. And I'm gonna connect X to X and Y to Y. Remember, we set it to 2D reading the 2 axes. And then connect trigger to trigger. All right. And then for the turnaround, I'm gonna use add actor world rotation. And we're gonna split the rotation pin and then add in a multiply. All right, and we're gonna connect add value to here and then Z rotation. And this value here determines how fast you're turning. I'm just gonna put in 2. And similarly here, this determines how fast you're moving around. I'm just gonna use value 15. And then here with the VR pawn selected, we're gonna go into the details panel and then search for use controller, y'all. So on default, this box is ticked. Make sure that this is unticked. And then there's something else you can do is that sometimes on default here, you might have some visible mesh, because when we are inhabiting our character from first person perspective, I don't want the hand to be visible. I don't want there to be a visualization of my hand or my body. So if you see any visualization mesh here, you can go on and delete them. And then we can go into, with our hands right selected, we can search visible. If here your visible box is true, you can turn this off. And then similarly for hands left. Okay, we can see our scene here. And then since we've configured our VR pawn to be at the player start position, so you should be seeing, that's the perspective and location that you'll be viewing your scene from. So here we can see our light. And then so we previously configured the movement to be, the turning movement to be on our right joystick. So as you move your joystick, you should be able to turn around and see the scene. And we've matched the moving forward to our left joystick. So you can walk around and turn around in your scene. And here you'll see the lens flare and bloom effect that we added in earlier when you look at the very bright light source. So I'm gonna go to a bright light source over here to demonstrate the effect. Right there you'll see the lens flare. And how the lens flare look and the headset might be a little bit different from your Unreal editor. So you can go back and forth with the headset preview and your editor to adjust its effect. You can adjust its intensity and threshold in the post-processing volume detail panel, which I showed in the last step. So here we can all take a moment to just experience the scene that we built and then adjust your light intensity and lens flare intensity to however you like it. And once you're satisfied with your scene, Then we can take down our headset. And we can hit exit to exit the VR preview and go back to our scene. And now we're ready to go into the next step, which is adding spatial audio and sound sources to our scene. What is spatial audio? To talk about spatial audio, we should begin with the most common format of sound, stereo, which means two-channel. This is the most daily format we use in our everyday life with our headphones, computer, and TV. Imagine if you're listening to music on your headphones. The sound stays the same no matter how much you turn your head. You have this clear awareness that you are listening to music, which is not part of the real world surrounding you. Spatial audio, however, goes a step beyond that. It is about breaking that boundary. If we compare it to vision, common stereo sounds are 2D and spatial audio is 3D. Spatial audio is about creating a three-dimensional sonic environment where audio appears to be originating from specific locations around us, mimicking real-world behaviors. Now, let us pause for a moment and think about the idea of listening. Humans and all animals use sound to situate our bodies in the world. For example, when a sound occurs in space, there is a slight time difference between when it reaches your left ear and your right ear, and that is how we subconsciously locate the sound source around us. Back in time, it allowed us to identify the locations of our predators. The same ability that enabled our survival is still within us and is now ingrained into our natural instincts. And that is just one of the things that spatial audio can simulate. And that is why it is so powerful. Through simulation, tapping into our human basic instincts to enable immersion. Now it is commonly used in gaming, VR, AR, and film. But now you might wonder, the VR headset is technically also in stereo, with speakers located on both sides. What makes it spatial? So sound can be encoded into specific spatial audio formats and then decoded back again into stereo for the headset. The specific techniques used in VR is called head-related transfer functions, which simulate how ears process sound direction, while ambisonics capture full-sphere audio fields. Well, the good thing here about our neural engine is that it does the simulation for us. So we don't need to get behind the complicated process of encoding and decoding. By placing a sound source in our scene and adding attenuation, you can easily simulate the effect of sound coming from a specific location. And what is attenuation? Attenuation is creating spatial effects as the audience approach or move away from sound sources. It simulates real-world sound decay, making distant sounds quieter or muffled, and closer sounds louder and clearer. And it changes the perception of the sounds as you turn your head around. So now let's jump into it. And for our sound sources, we're going to use audio from the NASA Sound Library. This link will be in our file. So once you go onto the website, you'll see you have a variety of options. You can go into the NASA SoundCloud. And SoundCloud usually downloads WAV file, which is a file format that can be immediately used in Unreal Engine. So that is good. And you can just click on the three dot over here to download file. Some of the file you couldn't download it. So this is just a setting by whoever uploaded the file. For example, this one, it doesn't have a download option. And you can also go into these few playlists over here. For example, Sounds from Beyond. So this is recording by rover on Mars. And I can go into this one. And you can just download this file over here. And again, it's giving me a WAV file, so that's perfect. And there's also option from data sonification. For example, I can go into Sagittarius A. And what's interesting here is that you'll find out that these sounds are actually not recorded in the universe per se, but they are translated into sound from an image. So as I explained here, the detailed process, basically this image is scanned from left to right, and the brightness of that certain point on the image correspond to the volume. So as it scans left to right, the brighter the point is, the higher the volume is. And then the vertical position, say of this dot, correspond to the pitch. So imagine this image is scanned to here, and then we are listening to this dot. The higher it is on the vertical axis, the higher pitch it will be. And the brighter it is, the higher volume it will be. So for example, on this image, the center here, which is the brightest, will be the loudest volume as this image or this track is played from left to right. And data sonification kind of can be applied to many things. You kind of can think of like everything can be converted into number or data in one way or another according to a certain standard. For example, here, brightness and location. And then that number and data can then be used on volume or pitch. So, and for this, we can use download here. And this will give us an MP4 file, which we're going to convert into Wave in a little bit. So let's take a moment here and just download some sounds either from SoundCloud or from the various playlists over here. So now that we have all of our sounds downloaded, I have them all in this folder. And remember, all of the data sonification files that we've downloaded were in MP4 format, not WAV format, so they couldn't be read immediately by Unreal. So what we are going to do is use Audacity and its external library. So you can download Audacity from this link. This will be attached to the file also. And when you open Audacity, go to Edit and go to Preferences. And under here, go to Library. And you are going to download this FFmpeg library. Will guide you to this link. Due to license issue, we couldn't download it directly from Audacity, so we're just gonna hit this install link, and you can download it from over here, according to whichever system you're using, and install this installer. So after that's done, you should restart Audacity, and it usually just reads the library that you've downloaded. A way to double check is that right now with that downloader, you can go to File and go to Open, and we are going to select, I know this last one is an MP4 file. And if your library is installed correctly, you should be able to just open this MP4 file. If it gives you an error, that means the library is not being installed successfully, so just repeat the steps above. And for our purpose, we don't really want much silence in our audio file because we'll be placing them around the scene, and they'll be triggered once the viewer approaches them. So right here, you can see that here I have a stereo file. And for the left and right channel of the track, there are the silence are kind of mismatched. So say I want to delete this part. I don't want to delete the same area on the left track. What I can do is I can right click and I can say split stereo to mono. So this will give me two mono tracks left and right. And I can just delete their silence portions individually. And then I can just go to, again, the same way. Mix 0 track. And we can just ignore it. This is because we kind of delete different part of the tracks. And now we can go to File, Export Audio, Save to Computer. Choose, make sure this is the folder of your sound. And we can just keep 0 and the sample rate setting as default. So now you can see that this originally an MP4 file is being exported as in WAV files. And we can double check. So in our folder, now I should have this file. So this is showing up as a WAV file. And I can just delete whatever I had originally. And we can use some similar process on the other files that I have, even on the other WAV files. So I'm gonna go and select this file. Okay, so this one doesn't really have much issue. Okay, so this one is fine too, but I guess I want to demonstrate something. Say if on your track part of the volume is much louder than the other and you want to bring them to a uniform level, what you can do is say I can select a certain part of the track using the select tool and then go on to effect, volume and compression, and then go to amplify. So this is, you can choose the decibel level. So for example, right now it's at 3.4. It means like the level of the selected region will be brought to 3.4 decibels. So say I can turn this down to -3. So say this is now the volume of it is being brought down to that level. And you can just apply this to different part of the track to kind of bring it to an uniform level if it's not. And again, after that's done, you can just do the same to export. And say you want an effect to be applied to the entirety of the track, you can just select the entire track and then go on to effect, amplify. If you say you download a track with very low volume, you can do that. And there are also some effects just within Audacity. You can change the pitch, you can add in delay, reverb, and distortion. We're not going to go into that right now, but you can experiment with that. So now just make sure that you kind of eliminate the silence in your tracks, convert them all to WAV files, and kind of bring them to an uniform level. And this is only if you want to keep editing this track within Audacity, you can save this file. But I don't need to, I've exported it. Okay. And now we are ready to go back into Unreal Engine. Okay, so now we are ready to import our sound. You can simply go to Content Drawer, VR Template, and Audio. And here you can hit Import and select all of the sound in your folder. If you get an error, it's usually because the format isn't in WAV. So if that's the case, you can use Audacity to convert your file. All right. And here you can click on it to kind of hear what they sound like. And the first thing we want to do is to add an overall ambience to our scene, kind of like a background tone or room tone. So wherever I'm in the scene, I'll hear the sound going on. And to do so, just go to Add Element, All Classes, and then go to Ambient Sound. And here, under Sound, you can choose, try to locate whichever one you want to use as your ambient. And then here I know I want to use this scan mic sound. And here you can use the volume multiplier to increase the volume, and you can also change the pitch. And it doesn't really matter where you place this icon because this will be applied to entire scene, just like the post-processing volume that we were using. Okay, and we can quickly test it out, not necessarily with your VR headset. You can just go into Simulate, and now we can hear it in action. So even if I go to a different part of the scene, I can still hear it. It's kind of being applied as an overall ambience. Okay, but just now we heard that there was a very abrupt stop because the sound file was only so long. So we will need to enable looping. To do so, go to your content drawer. So this was the sound file that I was using. And right click on it, create queue. And you can actually just name it ambience. And when you double click on it, again, we're back in the blueprint. And so we want to enable the looping function so that the sound is always playing as the ambience. So on right hand side here, you can just drag this looping element into the blueprint, and then again Alt and left click to disconnect the original pin. And we can just connect this player output to looping, and then the looping output to our speaker. Okay, so, and now we can go back, click on the ambient sound, and in the detail panel, we want to change this here to the sound cue that we just created. So I name it ambience. And so now let's test it out. So you can hear that the sound has been looped. And if you want the sound to loop more smoothly, what you can do is, so right now it's a little bit glitchy, you can actually go back to Audacity in the last step to add a fade in and fade out in the sound file. So to make a seamless loop for our ambient sound, we can go back to use Audacity. So this is one of the files I've downloaded. I'm going to go to a random point in the center, and then go to select at zero crossing. And then I'm going to go to right click, split clip. So what this basically did was it split our sound file at a point at zero crossing, a completely silent point. And I'm going to select this part and then cut. Then paste. And I'm going to select this area where the two are connecting and use a crossfade. Okay, so now we can test it out. If you turn on the looping, and we have our ambient sound now, and we want some localized sound. So for example, I want to only hear a sound when I'm under this light, and I want it to fade out. when I'm no longer in this light zone, and it will change as I shift my head. And for example, I want to apply that to the sound over here. We're just going to do the same, right click, create cue. I'm going to rename it to zone 1. And similarly, I want to enable the looping function. All right. And so now we can just repeat the step and then go into all class, ambient sound. And this time I want to place this at a specific location. Let's place it at this purple light. Okay, it's pretty close. And again, going to zone 1. Okay, so this already has the sound cue selected, but if it's not, make sure you select your zone 1 sound cue under here. And we're gonna do override attenuation, and you will see this 2 spheres appearing. And so this small sphere in the center is called inner radius, which means whenever I'm in the sphere, I will hear the sound source in full volume. It doesn't matter which point in the sphere I'm at. As long as I'm in it, I hear it in full volume. And then you see this gigantic outer sphere, so that's the fallout distance for this source, which means that from this point here on the edge of the inner radius to this very far out edge, the sound is decreasing from full volume back to silence. And then we can change the size for the inner radius and the fallout distance and the details panel. So if you go into attenuation, and here under attenuation volume, you can change this inner radius and the fallout distance. And I kind of want this to be in correspondence to the light sources that we have. So I'm gonna make the inner radius smaller, and then also the fallout distance. So kind of in this case, when I'm approaching this light source, I will hear our sound gradually fade in. And as I'm at the center of it, where it's the brightest, I'll hear it in full volume. And it will gradually fade out as I exit the light source. Okay, and let's double check on the volume multiplier. I can turn it up a little bit. Okay, so let's see how this play out. Okay, so that is our ambient sound, which applied to the entirety of the scene. And then I'm going to approach this first light source. Okay, you can hear it playing, but right now the volume is a little bit low. And as I approach the center of it, the volume gradually increases. And then it's fading out. Okay, so that's great. That's exactly how we want it. And you can always go back to change the inner radius and the fallout distance and the detail panel. And you'll notice as I shift around, it also changed my perception of the sound. And again, we can adjust the volume exit the simulation and go to Ambient Sound. And I'm gonna lower my volume multiplier, because I just want it subtly in the background. And then hit simulate. Okay, that's better. And now again, if I approach this, all right. And now we can just repeat the step and then add in different sound source at the spot where the light occur. And just gonna do the same, right click, create cue, then looping, sound zone 2. You can also place this higher up or lower, depending on how you want the viewer to interact with it. Well, I can place this one higher up. And similarly, we're gonna go to override, attenuation, and then go back to attenuation volume. You can also actually select different shape to experiment with, but I usually just go with the default sphere. And since this light is a little bit brighter, I kind of want this to be more intense, so I'll make the inner radius smaller. And I want to double check on my volume multiplier. And alright. So let's test this one out. Again, the ambient sound. Our zone 1 sound. Okay, so that volume is a little bit high. You can see as I approach this bright light, sound. Okay. So we can just repeat that step and do the same to have multiple sound source in our scene. And you can even add in multiple ambient sound. For example, you can add in a sound specifically only occurring at this corridor using the same method. Okay, so let's take a moment to add sound to our scene, and then we can start to preview our final scene in the VR headset. In our last step, we've added different sound sources at the location of our light source, and we've set their radius and attenuation. And now we are ready to experience how they sound like in our headset. To do that, simply go to, again, VR preview. And you can put on your headset. So now we're not hearing anything because we are really far away from all of our sound sources. And you can go on and approach one of them. And if you move slowly, you can hear it slowly fading in. So now I'm at the very center of my first light source and also our sound source that we put into the same position. And you can hear the volume is the loudest at this point. And as you turn around using your controller, you can hear changes in volume to simulate the change in your location. And if I exit this zone, you can hear it slowly fading out. And now a different sound is kicking in as I approach this different source. Okay, again, I'm at the center of it, and you can hear it fading in and the volume increasing. And as I turn around, I can hear it changing. Okay. And now, if I'm in an area that's completely dark, it will just fall back to silence. Now we can just walk around in our scene, approach different sources to see how they sound. And you can always go back to your editor to change its radius and attenuation so that you're satisfied with it. Now that is all set, we can just go back to our editor. So now we have tested our project and the VR headset. We're satisfied with it. We're going to go on and export the project. So there are a few things that we need to download. You can find them in this section of the workshop outline and download links. The first thing we're going to download is Android Studio. So we can just go on to this link and then download the latest Android Studio. Here I have already have it downloaded, so I'm going to open it. You can just install it on your hard drive after you've downloaded the installer. So here, once you open Android Studio, you're going to go into More Actions and SDK Manager. And under here, go to SDK Platform. You're going to see this list of options. But just make sure you have Android 13.0 API level 33 installed. And to install a new SDK, you can just select it and then click this download button. So here I already have it installed, but make sure you have the right version. And then under here, SDK tools, make sure you have the 36.1.0 version installed and also the 33 version. So again, you can just click on it and then select download. Okay. And then, so that's all set with Android Studio. And the next thing you're going to download is JDK. And here, make sure you download the JDK 17 version because that's what's compatible with our program. On default, this page might go to all versions, but make sure you download the JDK 17 version for Mac or for Windows machine, which is what I'm currently using. And so once you have these two things downloaded, you want to make sure to check on their file path on your computer. So here is usually under, if you go to your File Explorer, this PC and your hard drive. And I'm going to go to Users. And this is my username. And go to App Data. So here, if you don't see the App Data version, go on to View and Show and Hidden Items. So here you can see this folder icon is a little bit grayed out. That means that it's originally a hidden item. So go into App Data and then Local and then Android SDK. So here you should see the SDK folder under this file path. See your username, App Data, which is a hidden folder, Local, Android, and SDK. And here you should also see an NDK folder, which has your the correct version of your NDK, which is 25.1. And we're going to use the same method to check on the file path for our Java, our JDK. So again, go to this PC, your main drive, and then go on to program files. And you should see this Eclipse. And here you should see your JDK 17, which is the correct version that we have installed. Okay, so now you have double checked that you have these folders and all these file paths and they're in the correct version. We can go on and open our Unreal Engine and then go on to Edit, Project Settings. So here, first we're gonna set our level as the default map of our export. So here we are gonna go into Maps and Mode. So here under Default Maps, Editor Startup Map, and under Game Default Map, you're gonna select your current level. So my current level is just untitled because I didn't name it. But make sure, because this is the level that it's gonna on default export to. So make sure this is selected as the default as the level that you have built. All right, and then now we can go down to Platforms, Android SDK. And here under SDK configuration, remember how we just now find our folder in our computer. Make sure that these are selected as those file paths. So this is the location of your SDK folder. So for example, here, if I go to the dot, you're just gonna follow the same file path. So this is for SDK. I'm gonna go into C, and I'm going to go into users, my username, and app data, local, Android, SDK, and just select folder. And for NDK, you're just gonna select the subfolder inside the SDK folder. Make sure you also select this version folder, select folder. And for the Java, again, just the same step. You can follow this file path on the screen, which is C program file, Eclipse, and then JDK hotspot folder. And for the two API level for SDK and NDK, just type in 33 and Android 29. So that's the version of the SDK and NDK that we just installed in the Android Studio, and those are compatible with our project. Okay, so all of those are just settings for our export. And now we're gonna make sure our plugins are enabled. So go into Edit, Plugins, and make sure you have the OpenXR plugin, the XR Tracker plugin enabled. Yes, so make sure those two plugins are enabled. And again, I mean, you can still double check through the VR preview if any of your project file are missing, if any of your sound are not working, or if your VR pawn control is not working, you can still fix it at this point. But if you're satisfied with all that and all the settings went through, right now you can just go to Platforms, go to Android, and select Android ASTC, and select Development, and you can package your project. And you can just select a folder where this file is going to package to. I'm just going to package to my workshop folder. And you can show output log. Usually if if it runs into any error during the packaging, it will shows here, and you can see what is wrong, if you're missing any files, and you can fix it later. It usually takes about 10 to 15 minutes for the packaging. So once the packaging is done, you're going to see an exported folder with your project name. Okay, so after, say, 10 to 15 minutes, you should see this package complete. And right now, here I have this folder on my desktop, and I have my APK file with my project name. So you should be seeing the same. And so now we have exported the project. We are ready to migrate the project to our headset as a standalone application, and then we can experience the level directly, individually on our headset without connecting to the computer. So here, first make sure your headset is connected, which mine is right now. And you're gonna go to this link and download ADB App Control. So this allows you to see the current Android devices that's connected to your computer, and then you can install your custom application. In this case, it's the program we built in Unreal Engine onto the headset. So I've already installed, so I'm gonna open my ADB App Control. Okay, so after you've installed ADB App Control, you can just open it. And it usually takes a while for it to load. And make sure your headset is connected. So here I'll see my HTC Vive Focus Vision here. And then under Applications, you can just ignore this window. You will see all the app that has been installed on the headset. And then here, so I've already installed my game on my headset, so I'll see it here, but you won't see an Unreal project. But don't worry. What we are going to do is go to Install. And then here you can select Add APK. And then select and then find a folder where you just exported your project. So for example, here I have it on my desktop and this folder. So it will automatically locate the APK file. Just select Open. And I'm just going to overwrite this, which I've already installed. Let me double check. And now we can just select this file and then hit install. And it will just tell you task completed. And then now, once we go to our application, you should see your project name here, which means that it has been installed on the headset. So now you can go into your headset, and I'm going to transition this video to a headset recording to show you how you can access it. Okay, so now we have installed our SDK onto the headset. We can just go on and go to Library, and we should see our game right here under My Apps. So there you have it, our VR project. You've built a fully immersive experience from scratch. Dark space, guiding lights, NASA space recordings that grow louder as you drift closer. It's all yours now. Moving on, you can try swapping in different sounds, tweaking the lights, or expanding the scene. There's endless possibility. Thank you for joining our workshop. Great work today. Now it's time to explore your world.
this workshop has been beneficial for your practice and research. ARTSLab is a place where artists and researchers across disciplines can collaborate and explore new ideas. ARTSLab and CITH are here to support the community with education and accessibility to emerging technologies. If you have questions or would like to get involved with ARTSLab, subscribe to our email list or follow us on Instagram to stay up to date with our events, workshops, and exhibitions.